Okay, so let me continue with interfaces. Just a minute. Let me open my slideshow from last week. And last time I started to show you some important interfaces from the .NET framework. I showed you showed you some demo with the iComparable and iComparer, as far as I remember. And today I'm going to introduce iEnumerable to you and the iEnumerator interface to you. In Visual Studio, I will show you how to use them. This will be a little bit difficult. I mean, some guys love implement enumerators because this is what we are going to do. Other guys hate the same because it's kind of technical to code enumerators. You will see, but after this demo, I will show you an even easier way to use enumerators. But first, let me tell you something about enumerators, what they are and what we can use them, for what purpose we can use them. So let me open the project I used last time. This is a project with real estates, you know, buildings and lands and, well, real estates. And here, just a minute. Exactly. So here we have a land registry class, which actually, just a minute. I have to let Maminka in. Okay. So this class serves as a container class because it contains a list here with the real estates. And yeah, this is a very typical container class. You already implemented, I guess, a lot of container classes in your exercise class. So this is like those ones. But what I'm trying to do now in the main, let me just erase this. So in the main procedure, look at this. I instantiate my container class. I actually add real estate instances to this container class. There are some there is some data in a text file. So here I open the text file with StreamReader, and inside the while loop, I just generate real estate instances and I add them to this container instance. So what I'm trying to do now is that I would like to list all the real estate instances to the console, all the instances I have in this container instance. So for this, a for each loop would be really good to use. So how to use it? So I know that I have real estate instances inside my container instance here. And well, inside the for each loop, I'm going to write the details on the screen in this format, for example. Sorry, the first piece of data is the ID of the real estate. The next one is the price of the real estate in Hungarian forints. Okay, so this is a typical usage of the for each loop. But here I get an error message which says that, well, basically it says that the for each loop is not compatible with my container class, with the land registry class, right? So this is this is now my class. It's not a list, it's not an array. So actually the for each loop cannot find out how to enumerate the elements of my container class, like my container instance. So this is the problem. So what I'm trying to do in the next couple of minutes, it will be quite a long way, is that I'm going to make the for each loop compatible with my container class. So look at the error message again. It says, you see, land registry does not contain a public definition for get enumerator. So it says the land registry class here should have something inside which it doesn't have right now. And then this is a get enumerator something. It's a method actually. Okay, now let's look at the slide again. Yeah, so we are going to use this interface IEnumerable. It's, you know, it's the name comes from the property of being able to enumerate the elements. And in this interface, there is only one method inside this get enumerator method, the one which was mentioned in the error message. So this is what we need to implement in our container class. Okay, so let's do this. So back to my container class, here it is. And now I'm going to implement the IEnumerable interface. I have two of them. I'm going to use the one with the special parentheses. And here I can define what kind of elements, what elements of what type I'm going to enumerate. Well, these elements are of type real estate. Okay, so this is it. Now, what should I do? I'm getting an error message. Do you have any idea what should I do now? Anyone? No one. Okay. So first of all, let's check out the error message. The problem is that with this class of mine does not really implement the interface. I showed you last time that here you can find a drop-down list and you can click on the first element. This solves the problem immediately. You see? So actually the problem has been solved by inserting two new, no, not this one. Two new methods inside. Just a minute, my phone is ringing. Yeah, so those methods have been inserted by Visual Studio. And you see, this is the method which is needed for the for each loop, the get enumerator method. This is what I have to implement, which means I have to put the code inside. Okay, let's see what is the code. So this piece of code should return, this is why the name is get. It should return an enumerator object. The enumerator object is a small object which stores the current state of the enumeration. When I'm enumerating elements of something, I need to know where I am at this moment in the enumeration, and how can I move to the next element. Anyway, I have to return some enumerator which can enumerate real estates. For this, I need to create a new class. Let's call this new class real estate enumerator. So I will implement such an enumerator class. And again, this class will store where I am at this moment in the enumeration and how can I move to the next element. This enumerator class should know. Meanwhile, if you have any question, please raise it in the chat or by using your microphone. Okay, how to continue? Oh. Okay, so now we have an error message. Here, Visual Studio complains that this class does not exist yet. It does not. I just made it up. I just found out this name. So I have to create such a class. Visual Studio helps here as well. You can ask Visual Studio to generate a new class under this name. So let me try this. Okay, this happened. I have a new class here. This, you see, this is really nice. Visual Studio is intelligent enough to find out that this class should implement another interface, IEnumerator, because the IEnumerable interface and the IEnumerator interface always work together. I already used the first one. I implemented it in my container class. Now it's time to use the other interface. The other interface describes an enumerator. Again, it will store what is the current element of the enumeration and how I can move to the next element. So therefore, in this class, I have to implement those. Well, at least two properties and methods. Okay, let me show you this. So I'm implementing this interface now, and oh, Jesus Christ, two properties and 3 methods are inserted from this interface. So now, as I already told you, I need at least to implement this property and this method. I'm telling you, they are sufficient for enumeration. So let me think a bit. Yeah, I need a fix here. Back to my container class. When I instantiate my enumerator class, I definitely need to pass my list to this where is it? Yeah, to this constructor, because the enumerator should know what list I'm trying to enumerate. So let's just pass this list of real estates. This is a private list, by the way. So I'm passing this list to my enumerator. Of course, here I get another error message. This says there is no such a constructor in my enumerator class, and this is right because actually there is no explicit constructor in my class now. I should create one, but this is also supported by Visual Studio. It can generate a constructor of this kind. So let's click on this. Okay, let's see what happens. Nice. This is really nice, actually. As you see, Visual Studio not only created the constructor, but also created a a field for my list. The list I passed as a parameter. So the reference to the list I'm trying to enumerate is stored inside this field. This is really nice. So Visual Studio can help you a lot. Okay, so I guess you don't have any question yet. Then let me continue. So inside an enumerator, I have to enumerate the elements of this list. I should know where I am at this moment, which is the current element of the list. Therefore, I definitely need to introduce another field. Let's say I'm going to introduce an index for the current element of the list. So if, for example, if this is 0, then I know that the zeroth element is the current element. Then I increase it to 1, then to 2, then to 3. Yeah, so it's a good question. What initial value should I use here? Typically, -1 is used because -1 means we have not started to enumerate the elements, because there is no element at -1. Okay, I hope you understand this. Now it's time to implement implement this property. So as you know, I definitely need to implement this property inside my enumerator class. This is a property which have to return the current element of the enumeration. So this can be a read-only property which returns the current element. The current element, well, it's easy. I have to read the current element from the list, and this is the one at the index. That's it. So this, after all these preparations here, this is the easy. It's kind of easy to implement this property. Of course, before this, some checks would be nice about the index. For example, if it is still -1, then I shouldn't read the element of this at this index. Or if index is too great, I mean it's greater than the length of the list, then it's also a problem. Anyway, now I am skipping this part. If you want, you can finish this code. Okay, the last touch here. We have to implement this method. This is especially important because the enumerator should know how to move to the next element from the current element. So this is what I have to implement here. Okay, look at this. This method should return true or false because it can happen that the method cannot move to the next element because we already the current element is already the last element of the list. Then I cannot move to the next element. So in this case, I have to return false. So let's handle this error first. So what should I check? How can I know that I cannot move to the next element? What condition to write here? Please help me. What condition should I write here? Guys? Guys, Do you have any idea what condition to write here? How can I know that I'm standing at the last element of the list?
Yes.
Well,
No idea, sir.
no idea, no idea. Okay, here is my list, real estates. The index variable points to the current element of the list. So how can I check that it points to the last element of the list? You don't understand what I've done so far?
Index equal to list count.
Yes. Yeah, this is a good start. So what is the index of the last element? It's count. Count -1. Exactly. So if the index variable has this value, then it means I'm pointing to the last element of the list. So I cannot move move further, right? Exactly. Okay. Of course, if you want to play safe, then it's also bad if it's greater than count -1. Thanks for your hint, Shi. Okay. Otherwise, if I am able to move further, this is how I can do that. Index plus plus, and in this case, I was able to move further, so I have to return true. Okay, that's it. That's all you need for enumeration. The current property, so you should be able to return the current element of the enumeration, and also you should be able to move to the next element of your enumeration, and this is how it is implemented. Okay, I guess all of you are really excited if the for each loop is now working with together with my container instance. I cannot see any error messages anymore, so I have no error messages so far right now. So let's see what happens. Okay, it seems working. So these are all my real estate instances with the ID at the beginning. They have a quite complicated ID in Hungary, and the prices. But meanwhile, I realized I got an exception. So this exception, unfortunately, in Hungarian, but anyway, it happened that this method has been called by the system, and inside this method, I throw an exception. You see, this is inside my enumerator class. So I should implement this method here somehow. I'm not going to talk much about the dispose method. It's about you can free the memory or free other resources you used during the enumeration. But actually, in this very simple program, I don't use any such extra resources. You know from high-level programming languages one that the memory is freed automatically by the garbage collector. So, and in this very simple program, I don't have to free any resources by myself. In other programs, you might need that. Just imagine that, I don't know, you implement a program, an enumerator, which connects through the network to a server. On that server, you open a database, etc., etc. So after the enumeration, of course, you have to close the connection with the database and with the server, and this is what you would put here. But currently, I don't have to implement anything here, so I just leave this empty, and this solves the problem. Okay, the program works the same, and I get no exception now. Okay, that's it. So this is how you implement enumerators. Let me just summarize what I did. So you have to use two interfaces. The first interface should be implemented by your container class, you see. And in this container class, you definitely need to implement this method which comes from the interface. This should return an enumerator object. For the enumerator object, you have to implement the other interface. This is what I did here. Inside this enumerator class, you definitely need to implement the current property and the move next method. This is what I just did. The other methods are not that important. I'm not going to explain them. For example, the reset method, I'm mentioning this here, but I haven't implemented it. If you're interested in what they do, just look them up. Okay, do you have any question regarding this implementation?
No, teacher.
No, okay. Okay, if you check out the slides, you will find a very similar example with persons. This is almost the same, but the code is a little bit more sophisticated. And what I want to tell you is that this topic of enumerators is quite important. By using this magic keyword yield, you don't need to implement an enumerator, and this would be really great because this was the more difficult part. So let me show you how to use this new keyword yield, and you will see it makes much easier to implement enumerators. Actually, you don't have to implement the enumerator. The C# compiler does this for you automatically. There are two ways to use the yield keyword, together with return or together with break. I'm going to use yield return because this is what returns an enumerator, and this is what the for each loop needs. I'm not going to use the yield break command now. You might need that if you want to abort the enumeration at some point. You don't want to continue the enumeration. Now I want to continue the enumeration till the end. Therefore, I'm not going to use this. Okay, so look at what I'm doing now. I'm going to, first of all, I'm not I don't need to implement an enumerator. Therefore, I don't need this class here. You can see my screen? I guess, I hope so. Okay, I hope you see my screen now. So I don't need this class anymore. Okay, now you can see my screen now. Okay, then let me go back to this slide. So I'm going to use this keyword now, the yield keyword, together with the return keyword, which makes the implementation enumerator automatic. So I don't need to implement my own enumerator. This is why I can just get rid of this class. I don't need it. Therefore, let me delete this enumerator class from my code. We worked so hard on this, but we don't need that anymore. Okay, this is one part of the cleaning. The other part is that my container class doesn't need to implement the IEnumerable interface either, which means I can also delete those methods from here. So basically, I just backed everything back to normal. So this is the original version. Therefore, again, the for each loop throws an error message here. Okay, so what should I do now? I have to use those keywords. So let me show you how I would do this in a very easy way. So here is my container class, and inside my container class, I would create a property which returns the real estates one after the other. At first the first one, then the second one, then the third one. So basically this property will return all the real estates one after the other. So basically I'm creating a property, a public property for my private list, as always. But now the body of my getter will be a little bit interesting. So what is needed to enumerate all my real estates? The easiest way is, to use a for each loop. This for each loop basically enumerates all my real estates in that list. And I just need to return the current element X, right? So this is it. I have to traverse my list, the elements one after the other, and I return them. Yeah, but this is not okay. You know what is going to happen here? So the for each loop starts to execute, and immediately at the first element, at the 0th element, it returns and never come back at this point. So this does not work with a normal return, but it will work with a special return, the yield return instruction. Okay, let me explain what the yield return does. The yield return returns X, but next time when I call the same property, the for each loop will continue at the current position. So the for each loop doesn't restart. If I use a normal return here, the for each loop would restart again and again and again with yield return. the for each loop continues the enumeration where at the position I finished last time. You see, I hope you understand the idea. Okay, let's see. I have to fix this problem here. It says, it says that the type of the property is not an iterator interface type. You see now it says iterator, not enumerator. Anyway, enumerators and iterators are the same concept. Therefore, I already know what to do here. Basically this property should return not a real estate itself, but the real estate embedded in an enumerator like this. Right? Since this is what yield return does. Yield returns an enumerator, not the element itself, but it's but an enumerator which stores at which position we are at this moment and how we can continue next time. This is what enumeration needs. Okay, anyway, so this is what you need here. And if you did this, then we are almost done. Back to my main procedure here, I just need to use this new property of mine, reg.realestates, and that's it. Since this property returns an enumerator, the for each loop can use it instantly, and actually this will work seamlessly, as you can see. So now the result is the same. Okay, did you like it?
Yes.
Okay, thanks for the feedback. I love feedbacks. Please give me more. Okay, so that's it. I think this is very nice to use. It's so how to say, so straightforward. You see, basically for enumeration you need a loop, and inside the loop you need to return always the current element. And there is some technical side, so you have to use this yield keyword and this interface, but that's it. Actually, you don't need anything else. Actually, in the background, the compiler generates something like this on the slide with an enumerator class, but you don't have to implement this enumerator. This is implemented automatically, and this is the power of the yield keyword. Okay, let me show you one more thing. So of course, it could happen that in your container classes, you want to enumerate the same container different ways. For example, let's say this property here enumerates all the real estates. Let me create another one. Let me create an enumerate property which returns only the cheap real estates. Of course, this requires some filtering here. So let's see, cheap means that the price of the real estate is less than, I don't know, 50 million Hungarian forints. Okay, so if in my main procedure, I want to enumerate only the cheap real estates, this is what I'm going to enumerate here. Okay, so let's say these are the cheap real estates. Okay, let's do something else. in this program, I have two kinds of real estates. I have buildings and I have farmlands. So let's say I want only to enumerate the buildings, okay? Then again, here I have to do some filtering. This is easy. I'm using the is keyword. If X is a building, then I return. If it's not a building, I just skip it and move to the next element. Okay, I think you get the idea. So that's it. This is how you can very easily and very quickly write enumerators, and enumerators are really common elements in any object-oriented programs. Yeah, so this is why in C# you can do this in an easy way with, by using the yield keyword. Unfortunately, not all the OOP languages provide such a keyword for you. For example, Java. Java doesn't provide a yield return instruction for you. So you always have to implement your own iterators. In Java, they are called iterators, which is more complicated, but anyway. But other languages, for example, Python. In Python, you can find the yield keyword. Okay. Do you have any question about this?
Okay.
Not yet, teacher.
Okay, not yet. Okay, okay. Okay, then let me continue. I would like to mention some other interfaces. I'm not going to write any demo. I just using my slideshow now. Last time I explained to you that interfaces are built on the top of each other. They extend each other. For example, I just used now the IEnumerable interface. You can see an example here. And this is a very easy interface. It contains only one method, getEnumerator, and that's it. There is a more advanced interface which is built on the top of the IEnumerable interface, iCollection. This is the name of this interface, which adds an extra property. So iCollection has this property and also this method. Actually, you can also use the iCollection interface instead of the IEnumerable interface for your container class. So if in your container class you need to know what is the count of your elements in the container, then just implement this interface instead of this interface. If you want to make your container class even more advanced, you can implement the iList interface, which is built upon the iCollection interface. And the iList interface introduces those well-known methods, the add method, the insert method, the contains method. I guess most of you know all those methods from the list class. So this interface is even more advanced than the iCollection interface. I'm just trying to tell you that interfaces typically are built on the top of each other and they extend each other. You know, this looks like the layers in an onion. Yeah, so this is the overall picture of the interfaces. And in the .NET framework, this is what interfaces typically do. Yeah, there are so many interfaces. Last time I mentioned to you that interfaces are really important elements in object-oriented programming. Here I mentioned some other interfaces. Now I don't have too much time to explain those. If you are interested, please look them up in the internet. Rather we look into other programming languages. I already showed you this this slide about Java. Yeah, in Java you can find almost the same interfaces. I mean, the interfaces I showed you before, the IEnumerable, IEnumerator, IComparable, IComparer. So you can find find the counterparts of those interfaces in Java. And I also mentioned that there is no yield return in Java, unfortunately. In C++, well, last time, okay, do you remember if C++ has interfaces? So do you remember if C++ has or has not interfaces?
Hey,
Excuse me?
yeah, C++ has.
No, this was a trap.
Yes, because it can between each of class have multiple inheritance.
That's it. Thanks. That's it. So there is no need for C to use interfaces because in C++ you can use multiple inheritance. Exactly. Great. Okay. Since there are no interfaces in C++, unfortunately, of course, you cannot use those interfaces or their counterparts in C++. In C++, you have to use very mixed solutions for the same purposes. Let me explain one example here. Last time I showed you that in C# the list class has a sort method, and this sort method, you can use this sort method if you implement the IComparable interface or the IComparer interface. In C++, the list class also have a sort method. If you want to use it, if you want to apply it to your class, your own class, your class have to overload the less than operator. We learned about operator overloading in C# as well a couple of lectures ago. So actually you have to do this, you have to apply operator overloading if you want to use this sort method, which is kind of interesting. Yeah, and if you read the rest of the slide, you will see that if you want to mimic all the stuff I showed you in Visual Studio, you have to use very different kind of solutions in C++. So those solutions are not that standardized than in Java or in C#, by using interfaces. In Python, the situation is the same. I guess she would mention that Python also provides multiple inheritance. Therefore, it doesn't need interfaces either. So in Python, you have to use also mixed solutions, but the iterators, it's very easy to implement iterators in your class. Just look at this example. So here is a container class, my numbers. If I want to iterate or enumerate the elements in Python, I only need to implement those two methods. They have a fixed name, dash dash underscore underscore iter underscore underscore next, and I think you can figure out what they do. Actually, the next method is the more important one. Here, I move to the next element in my iteration. So this is a typical Python solution for this problem. Okay, so that's all. This concludes my slideshow. So if you have any question, don't hesitate to ask. Okay, no question. Then I would like to move to the next slideshow. The next slideshow is easier than the slideshow I showed you. So this is an easier topic. It's about exception handling, and I'm pretty sure you already know several details about exception handling in C#. So could you tell me what you learned about exception handling? Exceptions in C#?
Throws errors.
Errors, okay, exactly. So if some error happens, what do you do in C#?
If error happens, we throw into new.
Exactly. You throw an exception. So you learn the throw keyword and also the exception class, which you instantiate. So this is part of exception handling. If some error happens, you throw an exception.
Yes.
Have you learned anything else about exception handling? So for example, if you threw an exception, what to do with this exception?
We can check.
Again, please.
I guess we can check the error, and we can run the program if there is error.
Yes, exactly. And even inside your program, inside your source code, you can check the error.
Yeah.
Have you learned anything about this? What kind of keywords you have to use to check your exception?
Catch?
Yes.
Yeah.
Catch.
A catch keyword, and what is the other keyword? Try. Yeah.
Catch.
Okay, so you learned about this with Gabor Kuspel.
Yes, sir, in practice.
Great. Yeah, so this is it. Try and catch. Great, thanks. Okay, since you know how to throw an exception and how to catch the exception and handle this exception, you know the basics. This is why I'm telling you this slideshow is probably easier for you than the previous one. So now, in the remaining 20 minutes, I would like to talk about the background of exception handling. Because exception handling, how to say, exception handling is part of every object-oriented programming environments nowadays, but this was not always like that. Before object-oriented programming, there was no exception handling. programmers try to handle errors different ways. But fortunately, at some point, exception handling, I mean, the concept of exception handling was invented, and you and me are really lucky today that we can use exception handling, because exception handling makes error handling much easier than it was before. Therefore, now I would like to tell you some history of error handling, how error handling happened before exception handling. Okay. Okay, so if you look at the slide, it tells you examples, what kind of errors can happen during runtime. This is important. So just imagine that you use the Neptune system and some error happens. Meanwhile, you use it, so in runtime. And it's a good question what the system should do. It should give you an error message, you, the user, or it should stop working. What should it do? It should restart, or what? These are all good questions. So here you can see some similar runtime errors you might need to face too. If for example, if the user gives a negative number as input and you the programmer, pass it to the sqrt method, or in your code you are trying to open a file, but at the same time someone deleted this file, or you don't have enough sufficient permissions to open the file, what to do then, etc. You can imagine, I guess you can imagine even more such examples. So the fundamental question, what to do if your program sends some error, I mean, during runtime. I think all of you in your practice class typically write an error message on the console if some error happens, but this is not really a good approach. This is not a good approach. Just imagine that you are using the Neptune system, you as a user, and whenever a problem happens on the server, in the database, on the network, the Neptune system throws you an error message. What can you do, right? As a user, you cannot do anything. So I suggest you not to write error messages for the user. Maybe it's a better choice to write the error messages in a log file. And this log file can be opened by system administrator or by you as a programmer. In the future, you can just browse this file and see what errors happened. But this log file isn't displayed for the user. Okay, therefore log files are widely used in those kind of systems. Then the next question is, in what way your code should signal an error? This is in the title, how to signal an error. Since your code is since your code consists of methods, several methods, it's a good idea to make your methods to return an error code. So if inside your method some error happens, your method should return an error code. And based on this error code, we could find out what kind of error happened. Yeah, this requires some workaround in your code. For example, if you have a procedure cannot return anything. Therefore, you must turn your procedures into functions. You can try the same with constructors, but a constructor cannot be turned into a function. A constructor cannot return a value. So this is the first problem here. Constructors in OOP, constructors cannot be turned into functions. Therefore, the good question, how a constructor could signal an error? There is no way. You can see an example here. You already use the StreamReader class, to open a text file and read from this text file. And this is how you did this always. You call the constructor of the StreamReader class. What happens if inside the constructor some error happens? For example, the file cannot be found. How to signal this? There is no way. So this is a real problem here in OOP with constructors. Okay, other problems with this approach. So this was the approach what everybody used before exception handling. Everyone implemented functions, and those functions returned special error codes, special values. But there are several problems with this approach. First of all, just imagine you write a small piece of code. For example, this code opens a file, then you read from this file, then you make some calculation in this file, then you send the result through the network to someone, then you close the file. This is, I don't know, at most 10 lines of code. But so many errors could happen meanwhile, while opening the file, while reading from the file, while doing the calculation, while opening a network connection, etc., etc. So many errors could happen in these 10 lines of code. Therefore, you need to add if instructions to this code. You should check if some of the methods return an error code, and if they do, you have to do some, you have to handle that error. So just imagine you add several if instructions to these 10 lines of code, and this is not only 10 lines of code anymore, much, much more. The problem with this that this error handling code overcomplicates your code. Your code gets blow up, and the valuable part, these 10 lines of code, just how to say, just hides in this inside this huge code, so it's completely invisible. This is not a nice way of coding. Of course, there is another problem. If in a software project several programmers code at the same time, all of the coders have to know what are the special error codes and what they mean. If someone remembers this in a wrong way, someone does a mistake and handles another kind of error, then some critical problem could happen. Yeah, and etc. So this old-fashioned error handling suffered from several problems. And there is more. So typically in big software projects, the project is separated into layers. What you can see on the screen is the most basic layered model with 3 layers. The lowest layer has the lowest layer does data management. So typically this layer opens databases, queries from those databases, insert to the databases. So it's all about collecting the data. I think you already know what SQL or SQL is. This is the language for database management, and typically programmers who are working on data management know SQL very well, and typically such coders work on data on this lowest layer. Coders like you or me typically work on the middle layer on business logic. Business logic is about using the data for calculations, using the data for sophisticated algorithms. So all the stuff you learn using, you are the ones who write enumerators or implement interfaces, your own interfaces, and so on. And the topmost layer is called the user interface. I only have 1 minute, so soon I will disconnect. So user interface, you know what it means. You want to display something on the screen. What is important that you who work on the business logic should not display anything on the screen directly, because the user interface can be exchanged. At this point, we used a console, but next time, let's suppose the user interface will be changed to graphical user interface or web interface, and your console write lines instructions wouldn't work anymore. So this is a very important problem. Okay, now I stop. So this is where I will continue next time. So see you next week, guys. Bye-bye.
See you, sir. Bye-bye.
See you. Thank you, teacher.
See you.
Bye.